With the change in the global discourse towards sustainable cities, Kuwait recognizes the need for a proactive approach towards climate risk management, clean energy, and green economy. The Kuwait Institute for Scientific Research is front and center in this evidence-based discourse, investing in research and delivering viable and innovative solutions for green energy. Seawater desalination process, besides of fresh water, produces undesired levels of high concentration solutions of salts, known as brine. This brine waste is discharged into water or inland, which tends to contribute negatively on the environment. This patented desalination system tackles the environmental concerns attached with the standard desalination process by introducing a new system and method of treating the high-concentrated liquid discharge. The invention is a desalination system with mineral recovery properties using spray drying technique, which allows both the production of purified water and the recovery of mineral salts. The system is a two-stage system for zero liquid discharge, ZLD, desalination of feed. The system can be used in different industries that require fresh water in its production operations and industries that tend to produce brine. Since this is a ZLD technology, this system is ideal for regions with active ZLD policies. Water is a precious element for life on Earth. Even though nearly 70% of Earth's surface is covered by water, there is severe shortage of drinking water globally. Desalination of seawater appears as a solution for the water shortage problem. The patented invention is a combination of reverse osmosis and forward osmosis technologies for desalination process to optimize the benefits from both processes. The process starts with the entry of saline water into the FO and RO systems connected in series and is purified into fresh water. The brine from RO, which is usually dumped back into the sea, is injected back into the FO system to dilute the saline water source. By this, the operating pressure at RO system was dramatically dropped to 30 bar, which is not observed elsewhere and is the major breakthrough in the process. This KISSA invention benefited with the minimized operation costs, process reliability, environmental friendly process, and a low-energy seawater desalination process. In addition to the current sources of energy being used worldwide, hydrogen is considered one of the cleanest and most promising energy source to be used in numerous applications. At KISSA, we have developed composite of magnesium hydride powder with zirconium nickel powder and niobium oxide catalyst that forms a nano-composite system for hydrogen storage at low pressures and temperatures. The nano-composite system is formed by combining magnesium hydride powder with zirconium nickel and niobium oxide catalyst, forming a mixture and performing reactive ball milling on the mixture. Therefore, the nano-composite system can be used to extract the hydrogen at 10 bars and around 200 degrees Celsius, which is significantly a more cost-effective operation. Hefty volumes of waste are generated globally every year, such as plastics, end-of-life tires, household and commercial waste, and paper and cardboard waste, and the environmental impact of wastes is significant. A bench-scale reactor that is part of a fully integrated system that can perform thermochemical conversion and online analysis has been patented as of late by the Kuwait Institute for Scientific Research, with the aim of waste-to-fuel work. Co-conversion of different feedstock materials can also be performed in the reactor that is of a fixed bed type and has 3 separated heating zones. The invention can enhance waste management while generating useful products in the process. the waste materials are converted to renewable fuel, factualizing future energy aspects of waste-to-energy and fuel research. Stainless steel is a metallic alloy in which its usage was proven to be essential in many of today's industries. This is because the material possesses anti-corrosion and wear resistance properties, which makes it a very favorable material to manufacturers. This is why a method for synthesizing stainless steel thin films using an electron beam physical vapor deposition (EPPVD) device was developed. The new method relies on homogeneously depositing elements of stainless steel on the target's surface. The novelty of this method is based on the utilization of the EBPVD technique, which is employed solely to deposit thin films of any grade of stainless steel from evaporating an alloy source. On the commercial scale, this new approach is promising for coating the outer surfaces of pipes, heat exchangers, vehicles, turbine and compressor blades, and even household tools. Hydrogen fuel is a clean source of energy, which produces only water when consumed. Also, it can be used in fuel cells applications and in internal combustion engines. We have invented a method of doping magnesium strips with nickel powders using a cold spray technique. The method for doping magnesium with nickel, which includes cold rolling technique to produce thin magnesium nanostructured strips starting from commercial magnesium rods. Proposing a cold spray powder technology for coating the cold rolled magnesium strips with nickel powders at nearly room temperature. Applications are fuel cell applications in automobile, power plants, and automotive. The conventional rubble mound offshore breakwater built for erosion protection by sea waves is expensive for countries like Kuwait because we need to import good quality stones from abroad. Also, it has negative impact on the benthic marine life. It affects free water circulation, fish migration, and water quality on the coastal side. In Kissa, we invented vertical porous wave barrier, which consumes only 10 to 15% material when compared to conventional rubble mound offshore breakwater. Hence, capital cost saving of about 50% is possible. This innovative wave barrier is easy to build in a factory, assembled quickly in the field, appears beautiful with less environmental issues. Solar energy is considered the most abundant energy resource on Earth. With overtime usage, the panel's power efficiency is significantly reduced due to dust accumulation, which makes the maintenance and cleaning process costly. In Kissa, we invented a device and method for measuring the effect of soiling on the performance of a PV device. It utilizes a single PV device that is shifted between 3 stations. When 1 directly exposed to illumination, 2 placed under a cleaned glass, and 3 placed under soiled glass. A soiling ratio and soiling loss are then calculated through the measured electrical parameters in the 3 stations to monitor the performance of the PV device. This is useful for commercial and academic soiling studies, PV device performance and designs, and technology assessments. Kuwait has a crucial role in achieving Vision 2035 and New Kuwait Plan. In collaboration with private and public sector stakeholders, the Kuwait Institute for Scientific Research, as a leader of technological and scientific research, will continue to develop and contribute to the targets of sustainable living environment and diversified Kuwait knowledge-based economy. Striving for green energy is the future of sustainable cities.